Today's lesson, we're going to use box plots to display data. We've already used dot plots and histograms to display data, and today we're going to talk about box plots. What is a box plot? Why do we use it? A box plot is a graphical display of data that shows the spread of the data. So that's really what we use box plots for. It will show the spread of the data, and I'll show you what that means as we go through these examples. You may also see this referred to as a box and whisker plot. That's actually the terminology that we used whenever I was younger, many years ago. But now we've shortened it, and you'll typically see box plot. It shows 5 key features of the data. It's going to show the minimum, the maximum, the median, and then something new called the first and third quartiles. Let's look at example number 1, and hopefully everything that I just read will make a little more sense. This says the school basketball team scored the following number of points in each of their 16 basketball games. Determine the median and the quartiles for the data set and construct a box plot for the data. Then answer the questions that follow. We know we need to find the minimum, the maximum, and the median for the data, which means what do I need to do first if I'm looking for those values, especially the median? I need to order this data from least to greatest. There's 16 numbers here, so you need to make sure after you order them from least to greatest, you count and make sure that you have 16 values there. But what I want you to do is pause the video, go ahead and go through this and order this data from least to greatest. And what I like to do is, okay, 60 is the lowest number. I cross it off and I'm going to write a 60. And then, oh, I'm sorry, 60 is not the lowest value. 55 is. That's the lowest. 60 is next. It's the second lowest. And then I might go through and I see, okay, there's 62 and I have one of those. So go ahead and pause the video and do that now. Okay, I've ordered these values from least to greatest, and now we need to find, the first thing I'm going to find is the minimum and the maximum, and those are pretty easy to find. That's my lowest value, which is 55, and my highest value, which is 90. You also might see this referred to, and I'm going to write AKA ... a lower extreme. That's your minimum. You just might see it referred to this. That's your lower extreme. And your maximum value, your highest value, is your upper extreme. You just might see this terminology used. There's a lot of different vocabulary here. So you might see that terminology when you're asked questions on anything. What's the upper extreme? What's the lower extreme? And then now we're going to find the median of the data. I know that I have 16 values here because these are the points scored in 16 basketball games. That's an even number. I can split it right down the middle. That means the lower half will have 8 scores and the upper half will have 8 scores. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Right here, here's the lower half of my data, and that's 8 games. Here's the upper half of my data, and that's also 8 games. And I won't write games, I'll just write 8, otherwise that gets to be too much. Which means my median is directly between these two values right here, 75 and 77. When I have 2 values in the middle, what do I do to find the median? I take the mean of those 2 values. So I'm going to take 75, I'm going to add it to 77, and then I'm going to divide by 2. And what do I get? I get 76. So the median of this data is at 76. That's the middle value. So now your first and third quartiles. The first quartile, this is called, let's use a different color. Let's use orange here. Q1, you might see that. You might also see something called the lower quartile. This is the lower quartile. So why is it called a quartile? Well, we split this data. Well, the first thing we've done is we've split it in half. right? We took our median, so we can see the lowest value here, and then the median, the middle of the data. We can see the middle of the data and the highest value. So we split it in half. What we're going to do is we're now going to split each half into half again. By doing that, we're taking our data and we're splitting it into fourths or quarters. And so what we're going to be finding is the median of the lower half, but we call that the first quartile. So the median of the lower half, I have an even number of values here. I have 8, correct? I have 8 values here, which means the bottom 4 values are right here. And the upper 4 values are right here. I have 2 values in the middle, 69 and 72. I need to find the mean or the average of those 2 values. So I'm going to do 69 plus 72, and then I'm going to divide that by 2. And because I've already done the math here, I get 70.5. So right here, this value is 70.5, and that's the first quartile. 70.5. It's the median of the lower half, the middle value of that lower half. Now let's find the median of the upper half of the data. I have 8 values here. Did I do that right there? I sure didn't. I didn't draw that right. 1, 2, 3, 4, 5, 6, 7. This should have been, let's see. Let's do this. Right there. That makes more sense. In the upper half of the data, I've got 4 values here, and then I've got 4 values here, which means my median of that upper half is going to be right here, in between 82 and 83. What do I do to find the median or the middle of those 2 values? I take the mean of those 2 values, so 82 plus 83, and then I'm going to divide by 2, and I get 82.5. It's basically those 2 numbers, it's the number directly in the middle of those 2 numbers, so that's 82.5. And now we have our 5 key features, our 5 key values. So this first quartile, Q1, can also be called the lower quartile. The third quartile, Q3, can be called the upper quartile. So all of this is just vocabulary that you might see when referencing box plots. So now that I've found all of these values, I'm going to take each of these values and I'm going to construct a box plot with those values. So the first thing I need to do is figure out how I am going to scale my number line here and what values I'm going to use. So I know the minimum is 55, the maximum is 90. Let's just start at 50 and we'll end at 95, and I'm going to count by 5s. So I'm going to start at 50. There's 50, there's 55, 60, 65, 70, 75, 80, 85, 90, and 95. And I'm going to go with that. And a lot of students really struggle with this part, and that's okay. You will just get better the more that you do it as you get older, but I would just say use a pencil, and if you didn't do a very good number line, erase it and start over. So now let's write some values on our number line so we know what we're looking at here. I'm going to start with 50, and rather than write every one like that's 55, I'm just going to write every 10, so that's going to be 60. That's 65, and this is 70, 75, that's 80, 85, and that's 90. We just want to make sure that whoever is looking at this box plot can see what the values are. So now what I'm going to do is I'm going to show you how we display the middle half of the data. The middle half of the data, that's going to be right here. Okay, the middle half of the data. What I'm going to do is on this number line, I'm going to put my median, which is 76, right here, and I'm going to draw a little vertical line just like that. Okay, that's at 76. Then at my first quartile, which is 70.5, I'm going to draw another line, just like this. And then I'm going to draw another line at that upper quartile, or that third quartile, which is 82.5, which is going to be about, if that's 85, it's going to be about right here. Okay? So I've got 3 lines there, and I'm going to connect these 2 lines to make a box. That right there is the middle 50% of our data, right? If we have taken this data and split it into fourths, right, from 55 to 70.5, that's the first fourth. Then the second quartile would be from 70.5 to 76. And then the third fourth of the data would be from 76 to 82.5. And then the last quarter of the data is from 82.5 to 90. So right here in this box, we're looking at the middle 50% of the data. So I'm going to write that down. Middle, that's the middle 50% of the data. So now I'm going to show you why we used to call it a box and whisker plot. So there's our box, and then what used to be called whiskers were, we would put another line at the minimum and the maximum. So the minimum is 55, that's about right here, and the maximum is 90, that's about right there, and then you draw a line out to each of those. So there's what your box looks like, your box plot. What you might also see is you might see some people who put dots. That's why we called it a box and whisker plot. You will typically just see lines there now, but you could see it either way. So there's 55, and there's that, and then there's 90, and there's your box plot. So you can see the spread of the data. You can see where the middle 50% of the data is, the middle half of the data. You can see the last quarter of the data, which is right here. This is the last quarter of the data. That's going to be 25% of the data. And then you're going to see the first quarter of the data. That's right here, from that first line of 55 all the way to that 70.5. And it's really kind of hard to see, like, what is that value going to be? And, on this box plot, we can't really see it exactly. Is it 70.5? Is it 70.2? But we can see it's about 70. So here's your first quarter, which is going to be 25% of the data. And that's going to be right there. So we can really see the spread of this. Just looking at this box plot, I can see that my lowest value is 55 and my highest value is 90. And in fact, this first question here, let's go through these questions, says, what is the range of the points scored? Well, how do I find the range? I take my highest value, which is 90. I subtract my lowest value, which is 55. And that range is going to be 35 points. Question B says, what is the interquartile range, also called the IQR of points scored? So that's something new. The interquartile range is going to be, you're going to take the third quartile, and then you're going to subtract the first quartile from it. So the third quartile, recall that it is 82.5. And we're going to subtract that first quartile, which is 70.5. And when I do that, I get 12, which is 12 points. And that's my interquartile range. That's the range of the middle half of the data. That's very important when we're looking at box plots. The middle half of the data is very important. Let's move on to the median of the data set. The median of the data set we took, and that's 76. And then the next question, this is really the type of question that you'll see very often, is what number of points scored is greater than or equal to 25% of all other points scored? Well, it's important to note that when we're box plots, we split all the data into quarters, right? Into fourths. So if we're looking for the number of points scored greater than or equal to 25%, we're looking at the first quartile, okay? So if that number said 75%, we'd be looking at the third quartile. If that number said 50%, we'd be looking at the median. So that's really important when you're looking at, like, when you're hearing questions over box plots. So the number of points scored is greater than or equal to 25% of all other points scored. That's that first quartile, because this says 25%. That first quartile is 70.5. So it's 70.5 points would be greater than or equal to 25% of all other points scored. So then what are the benefits of displaying data on a box plot? Like, why do we use this? Well, the first is that you can easily see the spread of the data. So let's write that down. You can easily see the spread of the data, right? I can see where that middle half of the data is. And there I go again, saying data and data. I just do that spread of the data. So you can easily see the spread of the data because it's split into quarters or fourths, if you want to write that, if that makes more sense to you. It can handle large amounts of data because you don't see every individual piece of data. It can handle large amounts of data. So let's write that down. It can handle large amounts of data. And you don't see every individual piece of data. And then last but not least, you can compare different sets of data. Different sets of data. So what do I mean by this? I mean that you can put multiple box plots on the same graph or on the same number line. So we can compare two sets of data just looking at one graph. You can put multiple box plots on the same graph. And those are the benefits of using a box plot to display data. Let's move on to our last page of notes here. And we've got one more question, but we've got parts A through E to answer. So in example number 2, it says, Mrs. Brown gave her students an algebra quiz. She displayed students' quiz scores using box plots separated by her morning and afternoon classes as shown below. So let's first look at our two different graphs. She's got morning classes, and we've got her algebra quiz scores for those morning classes. I can see here's the middle half of the data. The lowest value is 20, the highest value is 100. So the highest grade in our morning classes was 100, lowest was 20. In our afternoon classes, here's the middle half of the data. It looks to be a bigger box. Our range is, a little bit more. Our highest value is at 100 and the lowest value is at 0. So now we've looked at our graphs, we've kind of taken a short little assessment of it, and now we're going to go through our questions. Question A says, what is the range of the morning classes? Well, that's going to be that highest value, which is 100, and I'm going to subtract that lowest value, which is 20, and that range is going to be 80 points. B, what is the range of the afternoon classes? Well, I'm going to take that highest value of 100. I'm going to subtract that lowest value of 0, and my range for her range for the afternoon grades is 100. Let's look at questions C and D. What is the interquartile range of the morning classes? When you're asked to find an interquartile range and you're given graphs like this, you're not going to be using numbers like 70.5 or 73.4, okay? You're going to easily see, okay, looking at the morning classes, that first quartile is right here, right, which is 70. And that third quartile is right here, which is 90. So the interquartile range for the morning classes is going to be 90 minus 70, which is 20. That's that IQR. The interquartile range for the afternoon classes, well, the first quartile is right here. It's the edge of that box, which is 50. The third quartile, or upper quartile, is going to be 90. So to find the IQR for the afternoon classes, I'm going to take 90, I'm going to subtract 50, and I get 40. Now let's move on to the last two questions here. We got to think about these. If Mrs. Brown has 68 students in her morning classes, how many students scored below an 80? Below an 80, well, I can see that an 80 right here is the median. You know what, let's change colors here. 80 would be the median right there, right? That means that half the students scored below an 80 and half the students scored above an 80. And if she has 68 students, that's an even number, right? So we're going to split that directly in half. That 80 would be the mean of those two middle numbers because it's an even number of students. How many students scored below an 80? We're going to take that number of students, which is 68, and we're going to divide it in half, which is 34 students. Because that 80 is the median, that means half the students scored below an 80, half the students scored above an 80. And let's make a little note here so that you know what you're looking at when you refer to your notes when you're doing your assignment. So we're going to take half because 80 is the median. So let's write that down. Half because 80 is the median. And now let's look at the last question of this set of notes. I'm sorry, I'm going kind of slow because you got to have some think time for these types of problems. Okay, so question F says, if Mrs. Brown has 72 students in her afternoon classes, how many students scored above a 90 on the quiz? Well, okay, a 90, well, that's the third quartile. How many students scored above a 90? What percent of students? 25%, or a fourth of the students scored above a 90, because we're not looking at the median anymore. We're looking at that third quartile, a 90. So if she has 72 students in her afternoon classes, half the students didn't score above a 90. A quarter of them did, which would be a fourth of them. So a fourth of 72. That's the same thing as 72 divided by 4, which is 18 students. Oops. And it's the third quartile. Let's make a little note here. This is the third quartile. Go ahead and write this down so you can refer to your notes later. It's the third quartile, so a fourth of the students, 1/4 of the students. And we just divided by 4 to take a fourth of that. And that concludes your notes over box plots. I do want to say one little thing when you're doing your assignment. If you're ever given box plots that are already graphed that you have to analyze, you really need to pay attention to, like 2 plots, how what the number line looks like. I might see visually 2 very similar box plots graphed, but like this one, let's just say, for example, this started at like 60 and it counted by like 20s, right? So 60, and that, that's 80, that's 100, right? And that'd be 120, 140. When this one over here counts by 10s and it looks like that. So just make sure that you're paying attention to your number line when you're looking at questions where you have box plots that are already graphed. But that concludes your notes over box plots. I hope it was helpful.